Hello. Thank you for being here. I'm sure that all of you have been, like we were just talking about, talking and hearing a lot about ChatGPT and LLMs and all of the interesting innovation happening in the space right now. We at Free Climb from Vail have been talking about it a lot too, and learning a lot. And we're excited to be here. And we've heard a lot of interesting things that have been done with LLMs and all of that jazz. We're just as excited as everyone else. However, among all of that LLM whirlwind of buzz, the way we wanted to make our contribution to the discourse surrounding all of that was to share some of our expertise regarding speech recognition in hopes that it might be helpful to anyone of the few of you out there who might be trying to implement a voice-based interaction with an LLM and an ASR. So, therefore, this is a little bit about why talking to your LLM might be harder than you think, but also hopefully some helpful information if you are trying to do that. So that's what we want to talk about. Now I'll tell you a little bit more about who the heck we are. I'm Sarah. Hello. I'm a conversational user interface designer / analyst, and my / analyst is there not just to make my title really long, but also because I specialize in language data curation and analysis and training and evaluating NLU models. And I work for Free Climb from Vail. Don't worry, you can call us Free Climb from Vail, you can call us Free Climb, you can call us Vail. Those are all fine, don't worry. We offer integrated communication solutions. We've been in that space and in the telephony space for going on 33 years. We take insights from our clients' data and business intelligence and turn it into exceptional conversational experiences. And the way we want to impart this kind of experience-based knowledge with you today is by walking through a case study, which is also kind of a war story of an experience that we had in a past project working with a third-party ASR, where we had to slightly change our battle tactics and come up with a counter strategy when our ASR betrayed us. Dun dun dun. A very dramatic tale that I will hopefully do a good job of telling you. So, oops, sorry, skipped one. So the project that I'm going to talk at you about for the next couple of minutes involved a customer service IVR system in the domain of wireless cell phone and data services. And the conversational pipeline we implemented in this project, again, like I said, used a third-party ASR to transcribe phrases and send them to an NLU intent engine. I'm sure several of you are familiar with a similar pipeline construction. And just to set your expectations as far as like expected types of utterances that we thought we would get in this kind of project were things like callers needing to pay their bill, buy data or buy a hotspot, or add or remove phone lines from their account, so on and so forth. You get the idea. So the problem we found ourselves facing in this project was we started seeing more callers being reprompted or transferred than we would have liked at certain points in the application. So we did have to obviously figure out why that was happening. So we did do that. Kind of had to get our hands dirty and get down in the trenches, if you will, to extend the battle metaphor a little bit, and combed through quite a few call logs to see what was going on. And when we did that, we saw some pretty weird stuff. Like, for example, in the call logs, caller utterances saying things like chutzpah or tosspot, whatever that is, and other super weird things, which probably seems suspicious to you. It certainly did to us. So we spent a bit of time listening to the audio for a lot of these calls, and surprise, these callers were not actually saying chutzpah or tosspot. They were saying actually domain relevant things like hotspot, but were being mistranscribed to things like chutzpah and tosspot and other like basically nonsense. Yeah. So unfortunately, these types of mistranscriptions were wrong enough or wrong in just the right way that it caused our NLU engine to not be able to get high enough confidence on an intent. Probably isn't surprising to hear that we didn't have chutzpah in the training data for the NLU. So Because that was happening, the only thing the system could do at that point was reprompt that caller to try again, maybe even more than once, or even eventually transfer that caller if that kept happening. So that is kind of the general description of the problem. We needed to get a better idea of just how extensive this problem was, and to see if we could find any patterns in the way things were being mistranscribed. So we compiled a very large list of mistranscriptions to see if we could find any trends, and we did find some trends. One interesting one being that this ASR seemed biased towards giving us names of both people and cities, which was lovely. Another interesting trend that's important to talk about here is we were getting a lot of miscellaneous substitutions that were very phonetically similar to what the callers were actually saying. And to solidify that with an example, we can look at the second one from the bottom, and I'll get out of the way. Wife, comma, I is a transcription that we got for when a caller was saying Wi-Fi, meaning wireless internet, which is interesting because I can make those two sound very different if I try really hard, right? Wife, I versus Wi-Fi. But in normal, natural, regular speech, such as what you get when a caller calls into an IVR system, those two are basically phonetically indistinguishable, which is a little frustrating. However, if we remember that the domain of this project was wireless cell phone and data services, wife, comma, I shouldn't really have been that likely of a candidate to choose for that phrase, especially not over something like Wi-Fi. That's very domain relevant. So what did that tell us? So these types of errors, especially those phonetically similar but domain relevant versus irrelevant errors, told us that our ASR that we thought we knew and loved and could trust stabbed us in the back. Meaning it seemed that this ASR was not trained very well for this domain, didn't seem very compatible for this project. Now, what compounded that problem for us was the fact that this, again, was a third-party ASR, essentially a black box to us, so we were not able to have an effect on the way that this ASR produced transcriptions. So, left us in kind of a pickle. What did we do about it? We took a two-phase approach to addressing the problem, kind of a long-term versus short-term approach. The long-term approach being to develop our own custom ASR trained on caller data and only caller data. But as some of you probably know, that does take a relatively substantial amount of time. So we did have to find a way to improve transcription accuracy in the meantime while that training was happening. So the interim solution that we pursued was to implement a transcription correction layer into our conversational pipeline that used word and phrase replacement via regular expression and a partial transcript evaluation mechanism. And don't worry, I'm going to talk more about both of those right now. So the regex replacement piece of that correction layer used a library of regular expressions that we curated based on call log data to identify common mistranscriptions and replace them with corrected words or phrases, kind of like you see here. So ultimately, we repaired those transcriptions enough to get high enough confidence from the NLU on an intent. So pretty straightforward. That other piece of the correction layer, like I said, was the partial transcript evaluation piece. Now, partial transcripts, if you're not familiar, you can think of them as previous versions of a transcript that an ASR worked through as it listened to a speaker speaking to arrive at a final transcript. And I always think it's easier to understand something with an example. So let's look at the example. For this phrase, you can see that the ASR gave us a final transcript of, I'm canceling my service with Acme Wireless. But if we look at the partial transcripts, aka the previous versions, you can see that this ASR originally thought the speaker said gasoline. And then it kept listening, and it changed its guess to counseling service when it heard the word service, because counseling service makes more sense than gasoline service. Then it kept listening and got the rest of the context of the phrase and finally settled on the final transcript of "I'm canceling my service with Acme Wireless." So that shows you a little bit about how partial transcripts work, or what they are. Now, our partials evaluation, the way that worked was it evaluated the NLU confidence for up to 5 partials whenever the original transcript we got from the ASR got lower than threshold confidence. And if we found a partial transcript that got high enough confidence, we went with that one instead of the original transcript. So that was regex replacement and partial transcript evaluation as part of the interim solution. Again, that long-term solution was training a custom ASR. Once training was complete, we were able to install that custom ASR into our production application and saw a huge improvement in transcription accuracy. Specifically, we saw a 28% reduction in word error rate, which translated to a roughly 13% improvement in intent recognition rate, which is the frequency with which our NLU could find an intent with high enough confidence. So if you've worked with NLU or ASR much, you probably recognize that that's something to be happy about. Yay. But if you haven't, or if you're otherwise wondering what 13% improvement means in the real world, you can think about it this way. Let's say this application received 150,000 calls per day. 13% more NLU match, which is our improvement in intent recognition rate, 13% across 150,000 calls per day, that calculates up to potentially almost 20,000 calls that are now getting routed correctly, aka are not going to the call center. And if any of you have to track containment as a metric, which a lot of us do, that relates directly to a boost in containment, which is great. We could even go a step further and think about this in terms of, it costs an amount of money per call to a call center. If we take that amount of money times 20,000 times every day of the week and every week of a month and every month of a year, I know how time works. In any case, it adds up pretty quickly to a nice chunk of change to not be spending on calls going to the call center. So I'd say we won that battle. Yay. To wrap this up with a bow, maybe some of you are thinking about doing this yourselves. This might be helpful to you if you are. This is a general outline of requirements based on recommendations from our experts on what it takes to train a custom ASR in terms of training data, expertise, computing power, the whole shebang. I did mention a second ago that it does take some time to train a custom ASR, so this fleshes that out a bit more. One thing that is unfortunately overlooked often is the time and resources needed for processing training data to do something like this. So we'd be doing disservice by not making that clear here, because it is something that has to be planned for, obviously. However, I want to say that we feel strongly that it's worth investing time and effort to do something like this, especially if we think about it in terms of the potential boost in containment we just talked about, or that cost savings. To me, I think those kinds of results speak for themselves. And I won't actually drop this mic, but you can pretend I did. So, if any of you are looking to do this yourselves, maybe you're looking for some ammo for persuasive power, bring back to your stakeholders, please feel free to take this. We also have a white paper that our data science team has written up, fleshing this information out in more detail and also telling the full story of the work that went into training the custom ASR for this project. They've done a really good job writing that up. My heart is so proud of them. It's also very accessible to anyone who's not a data scientist, so anyone would probably find it interesting and helpful. So please come by our booth if you are interested in that. We have them. We also have them digitally. Or if you thought anything else I said was interesting, please come talk to us. We're at booth 500. Maybe you have a war story of your own that you'd like to tell us about or have an ear to vent to. I'll be that ear. In any case, that is all I had. Thank you very much for being here. I appreciate it a lot. And okay, we've got 5 minutes, so if you guys have questions, I can try my best to answer them at least. Yes. Yeah, it was kind of a combination. I mean, we had a pretty good idea because we did some like pre-analysis, right, to kind of get an idea of like how bad is this really. So we had somewhat of an idea of where to look as far as like general topics that we're getting. Like for example, hotspot was a one that we had that was mistranscribed frequently. So looking for versions of that. We did a combination of manual analysis and a little bit of, I wouldn't necessarily call it all automated, but we did do things like with Python pandas and write queries to try and find things. And but it was somewhat manual just because it's hard to know what's in there if you don't already know. So it's a good question. I wish I had a cooler answer, but yeah, probably someone out there probably has a tool for us. Yeah. Anybody else? Yes. Hmm. Yep. How much better did we get with the interim solution? I don't have solid numbers on that, and there's a combination of reasons. One of them is we wouldn't necessarily wholeheartedly recommend that people pursue that over doing something like training a custom ASR. We're always going to be a proponent of doing it that way. The other reason is because a lot of that work happened in phases. It wasn't all at once. Like I said, there was a lot of analysis that had to happen for us to be able to fully kind of map out all of those things. So we don't have the same numbers to be able to compare them exactly right. So, but I will tell you, it was nowhere near the improvement of the custom ASR, if that's what you're wondering. But yeah, again, I wish I had a better answer. Yes. Yeah. 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 Yep. It's a good question. Yep. Anybody else? I think we probably have time for one more question. Or not. No? Okay. Um, okay. Uh, can you be more specific? A list of partials at what point? Mm-hmm. Service with Acme Wireless. Yeah. Oh, yeah. So we evaluated up to 5 maximum. So we started with like the most recent, meaning the latest version of that transcript. And if that didn't get high enough confidence, we'd look at the next one, evaluate that. And if it didn't get high enough, we'd look at the next one. We'd do that for 5, and then we'd stop and say, okay, this color is going to have to be reprompted. Good question. Thanks, Dave. Anybody else? Nope. Going once, going twice. Okay. Thank you guys so much. I really appreciate it. Signing off.